We are now at question 8 of this CXC CSEC May 2014 General Paper 2 exam video solution. And in this question, we are given a sequence of the number of dots that are used to form geometric figures, and we are given the first 3 figures in the sequence. So let us make some observations of the figures before we proceed to the questions. Now we will observe that we have a sequence of pentagons. Pentagons are 5-sided figures, 1, 2, 3, 4, 5. And in fact, these are regular pentagons. A regular pentagon is a pentagon in which all the sides are equal in length and also all the angles, all the internal angles are equal. We'll also observe that the dots are 1 unit apart on each side of the pentagon. So in figure number 1, the sides are 1 unit long and the dots are 1 unit apart. In figure number 2, the sides are 2 units long and the dots are still 1 unit apart. And in figure number 3, the sides are 3 units long and the dots are still 1 unit apart. But let's write down some of these observations. Now, as I said, the first observation is that we have a regular pentagon. A regular pentagon, as I've said, is a polygon with 5 sides such that all 5 sides are equal in length and all the internal angles are equal. A pentagon with 5 sides will also have 5 internal angles. The regular pentagon has 5 equal sides and 5 equal internal angles. Additionally, we observe that the figure number matches the length of the side. The figure number for each figure matches the length of the side. And as I've said before, the length of the sides in figure 1 is 1 unit. The length of the sides in figure 2 is 2 units. The length of the sides in figure 3 is 3 units. And so that pattern will continue. Also, we observe that the dots are all 1 unit apart in each figure. So let's move down now to the questions. Now, the first part wants us to draw the 4th figure. And to make an accurate drawing of the 4th figure, we could observe some dimensions on the 3rd figure, and in particular, it would be good to know the size of the internal angles between the sides of the pentagon. And to calculate the size of one of the internal angles, we could calculate firstly the total angles inside the pentagon and then divide that total internal angle by 5 to derive the size of one angle. So let's proceed. Now, firstly, the total interior angles of a polygon is given by this formula. When a polygon has n sides, the total of the interior angles of that polygon is given by this formula, 180 degrees multiplied by n minus 2. And that is because a polygon can be divided into n minus 2 triangles. And so, for this polygon, which is a pentagon with 5 sides, n will be equal to 5. And so the total interior angles will be equal to this formula, 180 degrees multiplied by 5 minus 2. And when we do that calculation, the total interior angles for this pentagon is 540 degrees. And because we have 5 equal angles in this pentagon, each angle can be calculated by dividing 540 degrees by 5. And when we complete that calculation, the result is 108 degrees. And so it means that each internal angle of this pentagon is 108 degrees. And we can therefore use this information to construct figure number 4. So for figure number 4, the length of the side must be 4 units. And so we can start figure number 4 by drawing a line that is 4 centimeters long. And this is it. And once we have our line that is 4 centimeters long, we can mark our dots 1 centimeter apart. And so this is the first side. And then to draw the side here, it will be 108 degrees from this line. We can bring our protractor in and we will measure 108 degrees from this side. And using the scale that goes from 0 upwards, this is the scale from 0 upwards, the inner scale. This is our 100 degrees and we want 108 degrees. This is 105 degrees right here. And so 108 degrees will be right here. And so we can mark that spot and then remove the protractor out the way, and we will draw the straight line through this point for that side. And we will draw the length of this line 4 centimeters long, and then mark the dots 1 centimeter apart. We will bring the protractor back in to measure 108 degrees on this side now, and this is it. So now we will measure our 108 degrees from this line using the scale that starts at 0 degrees, and that is 100 degrees here, 105 degrees here, and so 108 degrees will be right here, and we can mark that spot. We will now remove the protractor and draw the straight line through here 4 centimeters long, and that's it. That line now is 4 centimeters long, and this angle will be 108 degrees. We can now place our dots 1 centimeter apart, and so we have that side. Next, we will draw a line 108 degrees from this side. So again, we will bring back the protractor and position it carefully, and we are measuring 108 degrees from this line. And so we are reading a scale that starts at 0 degrees up to 100 degrees. So this line is our 100 degrees line. This is 105, and so 108 degrees will be right here. And so we can mark that spot and move the protractor out the way, and then draw our line 4 centimeters long through that point. And once we have our line in place, we can now mark our dots 1 centimeter apart, and there we have that line. To complete the pentagon now, all we need to do is join these 2 points with a straight line, and that's it. And this line will also be 4 centimeters long, and we can mark off our dots 1 centimeter apart on that line, and that's our pentagon. And to confirm that this angle is also 108 degrees, we can bring back the protractor and measure just to confirm, and reading the scale again from 0 from this line. This is our 100 degree mark, this is 105 degrees, and we see clearly that this line passes through 108 degrees. We can now remove the protractor, and there we have it, our figure number 4. Let's move down to part B. In part B, we're asked to complete this table, which shows the formula for how the number of dots in a figure can be calculated. And here we have the figure number in this column. In this column, we have the formula for calculating the total number of dots in a figure. And here we have the number of dots n. And so the figure number is f, and the number of dots is n. And if we observe the formulation, we will notice that the numbers here that are being multiplied by 5 are each 1 more than the figure number. And so when the figure number is 1, the number here that is multiplied by 5 is 2. That is 1 more than this. And when the figure number is 2, the number here that is multiplied by the 5 is 1 more than 2, which is 3. And when the figure number is 3, the number here that is being multiplied by 5 is 1 more than 3, which is 4. And in each case, we are multiplying by 5 and then subtracting 5. We must also observe that the final result for the number of dots is such that the number of dots is 5 times the figure number here, such that when the figure number is 1, the number of dots is 5 times 1, which is 5. When the figure number is 2, the number of dots is 5 times 2, which is 10. And when the figure number is 3, the number of dots is 5 times 3, which is 15. And we can use this observation to set up expressions in terms of f for the formula and the number of dots. And we'll do that in this row here. When the figure number is f, the formula becomes 5 multiplied by f plus 1 minus 5. This formula follows from the observations here. In each case, the formula is set up by multiplying 5 by a value that is 1 more than the figure number. And that's what we have done here. We are multiplying 5 by f plus 1. That is 1 more than the figure number. And then we are subtracting 5. For the number of dots, it's a simple case of 5 times the figure number, as was the case here. The number of dots is equal to 5 times the figure number. And now that we have this formulation and these observations, we can proceed to completing these 3 rows of the table. So when f is equal to 4, the formula becomes 5 multiplied by 4 plus 1, which is 5, minus 5. And the number of dots becomes 5 multiplied by 4, which is 20. When f is 5, the formula becomes 5 multiplied by 5 plus 1, which is 6. And then we are subtracting 5 again. And the number of dots n becomes 5 multiplied by 5, the figure number. And 5 multiplied by 5 is 25. When f is 6, our formula becomes 5 multiplied by 1 more than 6, which is 7. And then we are subtracting 5. And the number of dots becomes 5 multiplied by the figure number of 6. And 5 multiplied by 6 is equal to 30. And so that's it. We have completed the table. And let's now look at part C. Now part C wants us to write an expression in f for the figure number n. That is the number of dots that was used in the f figure. And from the observations we have, we see that that formula is simply n equals 5 multiplied by f. That is n equals 5f. That's our expression for n in terms of f. And that's the answer for that part. Part D now wants us to state the figure which contains 145 dots. That is when n is equal to 145. We want to find the value of f for which n is equal to 145. And so, if n is equal to 145, then it means from this formula here that 5f is equal to 145. And so to find f, we simply divide by 5, and so f will be equal to 145 divided by 5. And when we do that calculation, the result is 29. And so figure 29 will have 145 dots. And so that's the answer for that part, and that's the end of this question 8. And we'll do question 9 in the next video. See you then.